Hello everyone. Welcome back to our channel. We continue our exploration of logarithm problems in this series. Today's problem comes from AIME 1984, Problem 5. Find the value of the product AB given the two logarithmic equations shown on the screen. There are two methods to solve this problem. Method 1, systematic substitution. A standard textbook approach. It's best when you want the individual values of A and B, using direct substitution and algebra. Method 2, strategic, addition and symmetry. An Olympiad-style shortcut. It's ideal when you want the product AB without solving for A or B separately. This method exploits the symmetry of the equations and the fact that the product AB corresponds to the sum of logarithms. Let's walk through both methods step by step. Let's start with the systematic, textbook method for finding the product AB. Step 1. Convert all logarithms to base 2. To solve this system, we first use the change of base formula to make all logarithms share the same base. Since base 4 and base 8 are powers of 2, we convert everything into base 2. At the same time, we apply the power rule to simplify expressions involving powers of 2. After this step, every logarithm with base 4 or base 8 in both equations is now rewritten entirely in terms of log base 2. Step 2. Rewrite the equations. Next, we introduce substitution to simplify the algebra. Let x equals log₂a, y equals log₂b. Now substitute the simplified logarithmic expressions from step 1, along with these new variables, back into the original equations. This gives us a clean system of two linear equations, as shown on the screen. Step 3. Solve the system of equations. A quick and efficient trick is to add the two equations together, as shown on the screen. After combining like terms, we obtain a new equation involving x plus y. Factor out the common fraction 4/3, then multiply both sides by 3/4 to isolate x plus y. This gives us the result, x plus y equals 9. Step 4. Solve for the product AB. Recall our definitions from earlier. X equals log₂a, y equals log₂b. So, x plus y equals log₂a plus log₂b. Using the product rule for logarithms. Log C m plus log C n equals log C mn. We combine the terms. Log₂a plus log₂b equals log₂ab. From step 3, we already know this sum equals 9. Converting this logarithmic equation back to exponential form gives the product AB equals 2 to 9, which evaluates to 512. Summary of Method 1. The systematic approach, substitution. This method is ideal when you want the individual values of A and B. It follows the standard textbook procedure. Break down the logarithms and form a system of linear equations. Step 1. Change base. Convert all logarithms to base 2. Step 2. Substitute. Let x equals log₂a and y equals log₂b. Step 3. Solve the system. Use the two resulting linear equations to find x and y. Step 4. Calculate. Convert back to A and B, then multiply to get their product. Now let's move on to Method 2. If you look closely at the equations, you'll notice that adding them directly gives a much faster and more elegant shortcut, especially since the problem asks specifically for the product AB. Here's how this method works, step by step. Step 1. Add the two equations directly. Instead of converting bases first, simply add the left-hand sides and the right-hand sides together. This immediately gives us a new, combined equation as shown on the screen. Step 2. Group terms with the same base. Rearrange the expression so that logarithms with the same base are grouped together. Using the product rule of logarithms, log₈ x plus log₈ y equals log₈ xy, we combine each pair of matching terms. Notice that the product, the square of a times the square of b, can be rewritten as the square of ab. This allows us to simplify the expression further and obtain the final equation. Step 3. Simplify the logarithms. Since 8 and 4 are both powers of 2, we convert only these two logarithms to base 2. After converting, substitute the simplified expressions back into the equation. Now both terms appear in base 2, as shown on the screen. Step 4. Solve. Combine the coefficients. 1/3 plus 1 equals 4/3. Then multiply both sides by 3/4 to isolate the logarithm. This gives log₂ ab equals 9. Convert to exponential form. The product ab equals 2 to 9, which evaluates to 512. Summary of Method 2. The strategic approach, addition and symmetry. Best for finding the product ab quickly without solving for b or individually. This is the classic Olympiad shortcut. It takes advantage of the symmetry in the equations and the fact that the product ab corresponds to the sum of logarithms. Step 1. Add the equations. Add equation 1 and equation 2 directly. Step 2. Group by base. Collect all base 8 terms together and all base 4 terms together. Step 3. Apply the product rule. Use the logarithm identity to combine each pair into a single product. Step 4. Solve the composite. Convert to base 2 only at the end and solve for ab as one unified quantity. In summary, here are the two key takeaways. Method 1 breaks the problem into its individual components, finding a and b separately. Method 2 keeps the target, the product ab, intact from the start, leading to a faster and cleaner solution. Alright, it's time to wrap up. What did you think of the problem, the solution, and the two methods? Leave a comment below, and don't forget to like, share, and subscribe for more fun and elegant math problems. See you next time, and thank you for watching.